Hi guys, welcome to Learn Electronics Repair. Do you remember this? I had this a few weeks ago. This is from a guy over in the island of Fuerteventura. It's off a folding machine. This is for folding paper or card. It's for making magazines, basically for paper sheets, that sort of thing. And this was absolutely frazzled, burnt, blackened. Some of us, including me, were debating whether this was even repairable. So that's the condition I have it in now. I removed a lot of the components so we could see what was going on with this PCB. And here are the charred remains, okay, of the things that I actually removed. I've ordered a lot of new ones, okay, so a lot of new parts here that I've ordered for this. Some things I'm changing just because I couldn't easily test them. So, for example, these triacs, according to my analyzer, are no good, but it probably doesn't test such high-powered triacs, so I bought some more. There are a few things I need to remove, which I didn't originally, because I've got new ones. So that's the IC sockets and these opto isolators. I've got new sockets, I've got new optos. I'm going to remove the remaining electrolytic capacitors, so this one and this one. And these things, which I originally thought were fuses actually, or in fact electrolytic capacitors, I'm going to replace them with regular types. Some people commented that these type regularly fail, so you should kind of replace these on site really, but if you see them, just change them. These transistors I tested okay. LM339 I have. This looks like it didn't get burnt over here, but I have one, so can change that. The bridge rectifier tested okay. All the other diodes and resistors tested okay. These diodes are 1M4007 in actual fact. I know what they are. I will replace them. I could have put the original ones back in. I made a note of which ones came from where, but we know what they are, so 1M4007 will change them. This bit of the PCB needs a little bit more work. There were two resistors here. You may remember if you saw the first video that one was broken and I could sort of read the markings. The other one was just completely burnt up. I couldn't read it at all. And they were both broken, but I managed to determine one of them is definitely a 47 ohm and the other one may be a 100 ohm. Well, since then, somebody actually sent me a fairly high-res photo of this in an email, and I can just show you that. And here's one that somebody else sent me a photo of, that somebody, maybe themselves or somebody else, has repaired. So we can see they've changed the same capacitors, they've changed relays here. These are a different brand to the original ones. I'm doing the same. Okay. This is the resistor which I knew was 47 ohms, and they've replaced the other one with a 47 ohms, so they're both 47 ohm. We can see the 1M4007s here, so I can see what they've used. They obviously had different opto isolators to mine. They've changed one. They haven't changed the sockets they left them in, but I will change them. So we can see what they've done on this one, okay, with some equivalents. That's the red and green LED. And we can also see that they've actually changed the capacitors in this area, here and here. So that's what they've done, and that gives me quite a nice image actually, so I can see what I'm doing with this one, okay? If you're interested, I will just pop this onto my Google Drive, and if any of you guys find it any use, you can download it. First of all, let's try to clean this up a little bit more, and then we'll remove the other various components and change them as we go, and then we'll rebuild all this lot. Somebody suggested I use a fiberglass type pen. I didn't have one, but I've got one now. I've also been told that these work best with a bit of liquid on because the effectively is glass. Okay, so just try, but I think I'll agree with what they said there, that maybe apply at least some ISO or something. So we'll just dampen that area like so. Right, let's try this. I've not used one of these before, by the way, so if I'm using it wrong, well, Should have read the instructions, yeah. 40 FM. Yeah. But at least look at somebody else on YouTube and know how to use it. But it seems a fairly simple thing to work, actually. Yeah. It seems to work quite well, actually, as well. I have to say, I'm fairly impressed with this. So, Germany, Faber-Castell. Detlef gave me this, by the way. Faber-Castell. There's a barcode there if you can read it, okay? So, yeah, that's the thing. And, yeah, definitely an improvement. See where I've missed a little bit maybe here. What I'm left with here, I think this is literally just burnt into the PCB now, so this will not rub off as such. Let's just look under a microscope. Okay, so that looks a lot better now. We have this damaged area here. Sorry, that's the autofocus on the microscope, but there's no easy way for this to arc over, I don't think, from this one. Okay. Again, that's a little bit of damage to the PCB. These, I'm pretty certain, are just connected to those. I mean, they look that way to me. We can test that with a multimeter. This is one of the legs of the resistor, you can see there. And I could have looked to see where that goes, and then from that point I could effectively connect the resistor instead of to here to where it goes. If it's easy, I might just do that. We'll have a quick look. But other than that, I think that's pretty good. So guys, yeah, those are good. This damaged part here, this is not a pad. This is just holding the heatsink on for this device, okay? And the heatsink isn't actually connected to the circuit. It's not a ground point or anything like that, okay? So that's how it's looking now. Yeah, let's start to change these other components then. We can also make some other assumptions here. So this is the gate, okay, of these two devices. These are the actual devices. In fact, no, the other end is the gate. Okay, so that's the gate. And we can say that there'll be quite high voltage here because this is the main terminal. But the voltage on this gate will not be appreciably different, particularly from the voltage on the main terminal. At least that one, yeah, I think we can say that. So I think that is probably going to be okay. You know, we'll just have to find out, I think. Same with this one. This is the gate, okay. This point here, yeah, it connects to that anyway, so they connect to there and to here. These appear to be some sort of test points. That's what I think they are. I don't think there's a plug that fits there because the resistor was in the way anyway, okay. So I think we can say this is going to be okay. Let's change this other stuff and then we'll kind of work our way across the board. LM339, this is easy. I have original ones, you can see. I have no particular reason to doubt this one, by the way, and this socket also looks to be in good condition. We'll just check. This was a long way from the actual fire, which was started in these capacitors by the looks of it. So that is sorted. 7815 and 7915. We can test these because there's a transformer on here. So I'm going to power this up afterwards and we can just measure the voltages here. That will supply the op amp, or rather comparator, I would say. In fact, no, it's not. It's actually a transistor, that one is. That we can test. I've got to take these capacitors out anyway. Power it up, we can make sure this is actually working. These transistors I've already taken out and tested, they are fine. So the next thing then, after we've done this one, is going to be, let's do the opto isolators, and then let's get this bit sorted out. Next, we'll replace all these capacitors. The diodes and the bridge rectifiers have been tested. They all test okay. And we'll take this one out and test this one as well. It's some sort of transistor. C something or other. Oh, no, 2N rather, 2N6290. Okay. So let's get these off. I might have an issue with these capacitors because I don't actually have any of that sort of value. These are 2263. I seem to have a bit of a shortage of anything over 50 volt on capacitors. They actually test okay. The other option would be to fit some 47 microfarad 100. I know these capacitors are really not close tolerance at all, so I've kind of got one or the other. One is to test these and put them back in. I have tested them, I'll show you. So this one is 23.7, so very close to the 22. This one, yeah, 22.6. So it's kind of down to the lesser of the two evils. Because I don't know exactly where these are in the circuit, I'm loath to put the 47 microfarads in. So I think the lesser of the two evils in this case is to fit these. I want to get this thing back to him today. The other two, these are 220 microfarad, 63 volts. I have a whole bag full of these things, about 100 of them, so that's not a problem. I can fit those. These are brand new, you can see. But I will just test them, why not? So, yeah, 220. 220, okay. These ones, 1063. The highest I have are 1050s here. I have some 4.763s, and I can put two in parallel in replace of each one. That would give me basically 1063, and there's enough space here to do it, so I don't have a problem with doing that. That'll solve that one. So let's get these sorted, and obviously these two I can just change for the correct ones. I'm taking some care with this board because they're not actually marked, the polarity particularly. I mean, that might have a plus sign, so yeah, it is actually marked. It's okay. So positive this way round. And while we're here, we'll just test this. It read okay in circuit before, but we may as well just check it. Yep. Okay. I wouldn't be surprised if these read okay as well, actually, but we will change these because I can. No other reason really, other than somebody was saying those are unreliable capacitors. No, it reads about 12 actually. Okay, this one. Yeah, so they actually read okay as well, but we'll change those. Okay, that will work just fine. I'm quite happy with that. Right, so we have the LEDs here, and we have some transistors which I removed and I tested, but we'll check them again before we put them in. So the LEDs, it's not actually marked which is the anode and which is the cathode, but we have a flat edge on the silk screen here, so from that we should easily be able to work it out. Well, Google tells me that the flat side on the silk screen is the cathode. Flat denotes cathode. Okay. Yeah, much the same again. Cathode. I'll use these coloured ones because the original ones were. I mean, that's the least burnt of them. Cathode, I think, is a short lead. Let's have a look. Compare those analyzer. That's flashing away. LED. And the cathode is the red, so it's correct, yeah? So the short lead goes to that flat bit on the silk screen. Other one. Flashing away again. Red is the cathode, which again is the short lead. Okay. So we know which way around to put these. This is the remains of the burnt LED, the red one, yeah. Okay. certainly worse for wear. So we have two transistors here. Now these ones I tested on the previous video, they test okay. I can't actually read the markings on them, so I decided the best bet was just to put them back in again. Surprisingly, although they look a bit charred, they actually work. This one even looks a bit cracked, but it works. The other issue is I don't know what they are. I don't think they're anything particularly important. I seem to remember these drive the LEDs or the optical isolators, one or the other. I put a white mark on one. I'm sure that was to tell me which one goes where. And here is my drawing, or rather photograph, which I've drawn on, and we can see the one with the white mark. Okay, so they go back in. Okay, they're back in there. Now we have some resistors here. Again, I made a note and I took them all out. These actually read okay. I just took them out because they were so badly charged. So a couple of 2K7, which look like normal half-watt resistors, and a couple of 82 ohm, which were a bit bigger. This sort of size. That is actually grey, red, black. It reads 82 ohms. So let's change these. These are basically the same size as the ones that were in there. Plus 2K7, there's not going to be a lot of current flowing through this anyway. These are around the LEDs or the optical isolators. Yeah, actually probably need the vacuum tool. Thought they would have just come out. Never mind. I have a whole pack of resistors, 1 watt, but I don't have any 82 in the pack. It goes up to 75. The next one is 100, but we can easily get around this one. So we take a 10 and we take a 75, put them in series. That gives us 85, and that is near as damn it to the 82. Okay, and there's enough room to mount it this way on this PCB. It's not a problem. There's enough clearance in this thing. We can see the transformer is much higher. These are much higher, so this will be fine. Same with these heat sinks, much higher. Now the two 47 ohms. Looking at the size of the original ones, which are broken, but these are probably 1 watt as well. I have some 1 watt, I have some 2 watt. Let me see what will fit in there physically. Yeah, 1 watt look about right compared to how they were originally in there. Okay. I do have 2 watt as well, so if they'll fit, there's no reason why I shouldn't. Yeah, I mean, you know, you can't go wrong if you put a higher wattage in, can you really? These then yellow, violet, black, gold. So this is a 4-band colour. So 470 divided by 0.1 is 47. If you're not sure. 47 ohms. Okay. The capacitors which were here were very large. The replacement ones are actually the same rating but narrower, so I think that'll fit really well. Yeah, nicely. So we'll put the 2 watt ones in here. This one I'll just sort of position it slightly that way so there's a bit of clearance on the relay, because I've got plenty of space that side. Okay, so we have these capacitors, but first let's put these diodes in. I'm going to replace them all with new ones. Why not? The other ones all tested okay, but they were very blackened. Yeah, they kind of came out kind of like this. You can't even see the markings really. Okay, and we can see they all go in the same direction. So there's this transistor to put back in. We tested it before. I'll just do it again. It read okay. There's the 2 triacs that I just couldn't test basically, so they were probably okay, but I'll put new ones. The capacitors go here. These are the replacement ones, so you can see 0.22 microfarad X2. That's a specific type of capacitor. We need the right type. 275 volts AC. So I have 2 of those to go in. But it's probably easier to fit these first while I have some space to work. Here are the original triacs. I couldn't actually find a data sheet for these, but a subscriber told me what they were and told me the replacements to use for these. which are these type, BTA 16800. Okay, we see them here. So we're going to put 2 of these in. These are the heat sinks. I'm not sure if I have some more this size. I'll fit new ones, or rather replacement ones, which are actually not new but better than these. Yeah, I had some similar heat sinks, but I'm not quite sure they were going to fit properly. So I've cleaned these up. Yeah, that's using that fiberglass pen thing again. They're not perfect, but they're pretty good. That's the little tag that pulled out of the board. Yeah, I mean, this was heat damaged anyway, to be honest. That's my excuse. I can hopefully get this off before I burn my finger. Let's find out. Which is it? Finger or this will come off? Finger one. The original insulating, heat conducting things looked a bit distressed, so I'm going to put some new ones on. These are slightly bigger, but they'll fit fine. Okay. This also, I think, is slightly damaged. I'll position this because you can put them either way. These, I want to get the broken pin where the thing is ripped off the board anyway, sort of there. Then at least I can solder the other one properly. Yeah, that's the idea. The heatsink, as they solder, it doesn't actually connect to anything, so it's probably just there really for support. Yeah, physical support. I have the little plastic inserts. Again, this is not for electrical reasons. I think it's just so that the heatsink doesn't have any dangerous high voltages on it. It's not that you can actually touch anything. And we can see these went in that way round, yeah. We also see that from the photograph that somebody kindly sent me. Actually, thinking about it, I will change this transistor first. It'll just be easier to get in there now. Here it is, BRX49. Actually, this isn't a transistor. This is a sensitive triac or thyristor, something like that. This analyzer will test the small ones. It won't test the big ones, I'll show you. It might test these replacements. It wouldn't test the originals. I mean, you could say the originals were faulty. So this one, sensitive or low power thyristor. Okay. And these new ones, well, as I say, the original ones wouldn't actually test, but I do know this tester only will do sensitive thyristor and triacs, so higher powered ones it may well not test, but in fact it does test it. And the ones that came out, so they could actually be faulty. Well, I've got to change these relays anyway, so let's take these off as well. This is where this tool is really necessary, to be honest, guys. Or something very much like it. Okay, we have a bit more space now. So we'll change this one first while it's easy. Okay, so they are back in. They're all back in now. This test point thing has got a bit bent, but it is just a test point. I can see it's on the other one as well, so I'm not too worried about that, to be quite honest. It connects to this end of this resistor. Okay, can possibly straighten it a little bit, but this is probably a case of like leave it alone. In fact, he just wants soldering in actual fact. Okay. Similar with this other one, it's just a bit bent that way. Okay, let's have a look. Yeah, they solder here. Yeah, that's better now. Staying still, okay. So the last thing then are the relays. It's quite likely that these are actually okay, but I thought, you know, while I'm at it, and to be sure, let's change them. The same with these, so this one is quite probably okay. These two are most definitely not okay. So I have the replacement for these. Not SDS brand, but the same sort of thing. Okay, so you can see the same pin. S224V. Just a different brand of them, that's okay. Same 4 amp. Yeah. 120 horsepower, you can see 125 volt, 250, 3 amp. So all the same ratings, put those in. These will of course go in either way round, so we need to get them the correct way round. Well, the original ones went this way round, so they go like so. And we can also see on the photographs the guy sent me, I think somebody actually already used this type to replace the old ones. Actually, no they didn't, but we do see which way they go, yeah? We can also make sure this is correct because we can see that the coil is between pins 1 and 12, which is marked on ours 1 and 12 at this end. And we should be able to read the resistance of the coil. Yeah. There, 2.9k. So we know to go that way round. And these ones are much easier because, well, they only go in one way round. That's the first thing. So we can't get that wrong. This is the original one, S21 DC24V, S21 DC24VF. Those are the only ones I can find. I think the F means it's lead free in actual fact. Okay, AR2014 again with the F, I think it's lead free. We can see the rating on this, so it is marked 8 amp 380 volts, and we can see 8 amp 380 volts, AC 5 amp. In fact, it is 8 amp DC, that's 5 amp DC. So they're the replacements. Okay guys, so that's it. Just a little bit of charring around there, but as I say, I don't think it's going to cause a problem for the reasons I mentioned. All back together. And the other side, yeah. Considering the state this was in when it first came in, I think that's pretty impressive. Yeah. So we'll just try what I said. We'll see if we can just power this up. So just looking at this transformer now, this is 220 volts in. We can see there's a bridge rectifier over there, capacitor. This is 63 volts, so whatever the voltage is, it's going to be less than that. Okay. This looks like it's where the power is coming in, yeah, on this finger. In fact, we should be able to just trace this through actually quite easily. So this is obviously one end of the primary, it goes to here. The primary reads quite high, 2.3k, but for a low power transformer that's not unusually high. The other end of the primary then, let's see where that goes to. Here, to here, to here. It must come to onto here somewhere. That one, yeah. So we have power coming in here and here. We have the circuit there complete as we would expect. Yeah, there's 2 fuses there. So power this up from here. We can see goes to here. Other end of the primary goes to this one. Okay, resistance across here. Well, should read the resistance of the primary. Yeah, 2.3k. So we can power it up from here. I'm not sure if these are just double-sided, so I won't actually try and clip on here. I'll just solder one wire here and one wire here. And then let's have a look to see what's coming out of the transformer. So here we can see it goes to the bridge rectifier there. So we want to measure on the output of this. And we can see the plus and minus. Okay, that'll go to this capacitor. I can see this end goes to this one. And that one goes to that one. So that's where we can measure the output on the bridge. Okay, so let's just tag a couple of wires onto this. So we're going to power this up and we're just going to measure the voltage across here and see First of all, what supply voltage we have to this. Okay, the light bulb's in the series, so nothing happen actually. Light bulb didn't come on. 27 volts, that's good. So it's powering up, nothing nasty happened. Now we just want to check the voltage regulator. So the center pin will be ground, and then we'll have an in and an out. So we can easily measure actually here and here. Okay, so power it up again. Ground. What do we have? Well, you guys can actually see the meter. Nothing there. And nothing there. Interesting. Well, I don't see any voltage, but in actual fact, this may well not be supplied by this transformer, to be quite honest. I mean, we'd have to check, but this seems to me to be powered this way. From here. I don't see any connection resistance wise. We can just check this. So, well, the ground pin on the regulator is the middle pin, the center one. So 7815 center is ground. Does that go to our bridge rectifier here? No, the meter's working. No, that doesn't go to there. So if we go to the positive on the bridge rectifier, that also doesn't go to there. And to be quite honest, this is a 15 volt regulator. You would not expect that to be powered from a higher voltage over here, that much higher. It would be closer, yeah. So I'm thinking bridge rectifiers here. We can see more of them. Okay, coming in here by the looks of it, capacitors. We have this, we have more capacitors, we have this. So it would appear it's more likely that that actually powers from something else over here. Might be able to see. Yeah, the ground goes to there, so this is definitely powered from something else. The input on the regulator goes... Not exactly sure where it's here, so... Yeah, I'm not sure where that input comes from, but it could well come through a diode or something. But the fact the ground on here is not the ground on that means that this is not powered from there. So I'm not concerned. I didn't see any voltage on that. So what I will do, because I can't actually easily test the regulator, which is what I wanted to do. And I don't have the machine. I don't know how this thing connects up. I'll change this anyway, just belts and braces. I've no real reason to suspect that it's faulty, but no harm in changing it. I have one. Everything else on here has either been tested or replaced. So I'm confident enough now to send this back to the owner. I think it's very highly likely this will work. But at the end of the day, because I don't have the machine, it's not on the same island as me, it's something I can never say 100%. All I can really do is say that is my best shot at it, yeah? Okay, so I'm sure you lot down there will be chatting away, and let's talk together. And whether you want to chat or not, I hope I'll see you all soon on another video on Learning Electronics Repair. Ciao for now, guys.